Hey everyone, and welcome back to The Explainer. Today we're diving into something absolutely fascinating, the illusion of AI reasoning. We're going to look at what happens when you push today's most hyped models right to their absolute breaking point. So let's jump right in. To really get into this, we have to start with a pretty massive question. How far can AI actually think? I mean, we've all seen the crazy headlines, right? Right now, there's this perceived invincibility around advanced large reasoning models. You know, the LRMs, like OpenAI's O1 or Deepseek R1. They're acing complex math exams, they're writing brilliant code, and they honestly seem to reason just like we do. But, well, there's a catch, a really big one. The way we test them right now doesn't actually reflect the messy complexity of real-world problem solving. We are, quite literally, only seeing a fraction of the big picture. Think about it like this. Current AI is basically a world-class sprinter. It solves single, isolated problems with just unbelievable speed and accuracy. You ask a question, you get an answer. Boom. Done. It's a totally independent event. But the real world? The real world isn't a 100-meter dash. It's a marathon. Real-world tasks are multi-horizon. They require an AI to actually chain interdependent thoughts together over time. It has to plan, act, use the answer from step 1 to figure out step 2, and then use that to solve step 3, sometimes over thousands of steps.
And this brings us to a fatal flaw in how we currently evaluate AI. Researchers from Fudan University and the Meituan Longcat team really hit the nail on the head here. They pointed out that our existing testing paradigms basically only focus on immediate, single horizon tasks. Think about it. If we're only ever testing the sprint, we are totally blind to how the model handles a marathon. We've basically been giving these super smart models a single hurdle to jump over, when reality actually demands an entire obstacle course.
So to expose this flaw, these researchers built an incredibly clever stress test called the R-Horizon benchmark. Instead of just asking one isolated question, they compose interdependent reasoning tasks. They intentionally force the AI into a long horizon scenario by linking the questions together. Basically, they extract key information from one problem and create a strict dependency, meaning the next problem requires that specific answer to even be solvable. It's honestly a brilliant trap. Here's how it works. Step 1. Take an isolated math problem and its answer. Step 2, create that dependency. The next problem in the sequence uses a placeholder variable that can only be resolved if you got the answer to the first problem right. And step 3, this is the real kicker, the AI has to solve the entire sequence perfectly. It's an all or nothing score. If the model makes even a single tiny misstep anywhere in the chain, the whole thing collapses and it's a total failure. So what actually happens when you force these supposed genius-level AIs to run this R-Horizon marathon? Well, the twist here is pretty shocking. The researchers stated it plainly. Even the most advanced LRMs suffer significant performance degradation. When you take off the training wheels of those isolated single-horizon tests, the smartest models on the planet completely buckle under the pressure of multi-step dependencies. The data we're seeing from this is just undeniable. When tracking the accuracy of elite models like Deepseek R1 and the Quen series across really intense math datasets like Math 500 and Amy 24, the drop-off is severe. As the number of composed queries increases, moving from just one question to a chain of 5, the accuracy literally plummets. I mean, DeepSeek R1 drops from over 87% accuracy on a single Amy 25 problem all the way down to under 25% just by chaining 5 questions together. The marathon absolutely breaks them. Okay, but why? Let's put on our detective hats for a second and diagnose this breakdown. The researchers identified 3 very specific vulnerabilities. First, limited effective reasoning length. Basically, models hit a wall, say around 8,000 tokens, where their logic just starts to degrade. Second, constrained reflection scope. If the AI messes up on question 1, but it's currently chewing on question 3, it almost never looks back far enough to catch that earlier mistake. Its self-correction is way too hyperlocal. And finally, the third vulnerability, the overthinking phenomenon. This overthinking thing is wild. As the chain of problems gets longer, the AI doesn't just start making more math errors. The data actually shows a massive spike in what they call early stops. The AI literally loses its train of thought. It gets so overwhelmed by the interdependent context that it prematurely terminates its response and just stops generating before it even finishes the sequence. It is exactly like a runner just sitting down in the middle of the track and giving up. And the researchers found the absolute smoking gun for this overthinking phenomenon. The stats reveal that the AI greedily blows almost its entire computational stamina, its whole token budget, over-analyzing the very first problem in the sequence. By the time it finally reaches problem 3, 4, or 5, its brain power is completely tapped out. It has zero stamina left for the rest of the marathon. All right, so we've diagnosed the disease. Now let's talk about the cure. To understand how they fix this, we need to quickly reset with a key concept, RLVR, or reinforcement learning with verified rewards. In super simple terms, this is a training method where you optimize an AI's brain by only giving it a reward signal when it successfully reaches a verified, 100% correct outcome. Basically, it's how you teach a model to rigorously verify its own logic. So the researchers did something incredibly smart. They turned their own benchmark into the training tool. They took the exact same R-Horizon multi-step tests that were breaking the AI and fed them back into the model as new training data using RLVR. But they didn't reward the AI for getting just some of it right. No way. They used an all-correct reward. The AI had to successfully chain together every single interdependent step flawlessly just to earn one reward. They literally forced the AI into a marathon training camp. And the recovery? It's phenomenal. The data shows that models trained on this composed, multi-horizon data rapidly outperform models trained the old way on single problems. By training on composed data, the AI actually learns how to pace itself. It learns to manage its tokens, it stops obsessing over that first problem, and it learns to reflect over much longer horizons. The performance just shoots straight up. But here is the absolute best part, the ultimate payoff. The researchers discovered that training for the multi-horizon marathon actually made the AI a drastically better sprinter, too. By forcing the model to learn deep, sequential reasoning and proper token budgeting, its baseline accuracy on standard, single-horizon tasks, like the incredibly tough AMA 2024 math benchmark, shot up by a massive 7.5 points. That is a profound leap in intelligence simply by changing how it's taught to think about problems. So what's the big takeaway from all this? Well, current AIs, as brilliant as they seem, are artificially limited by how we test and train them. The R-Horizon benchmark exposes that boundary, but it also gives us the exact map to cross it. I want to leave you with this one final thought. If teaching an AI to hold just 5 sequential thoughts together boosts its intelligence this much, what happens to our world when AI can finally string together thousands or even millions of thoughts without ever breaking its stride? It's pretty wild to think about. Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll catch you in the next one.